Activity name is magnetic field due to straight wire carrying current. To perform this activity, the required material are small wooden frame like a stool, and I made a small hole in the middle of the flat surface for inserting the copper wire through it. Compass needles 4, battery eliminator, iron filings. Observe here, the copper wire is fixed through the small hole of the wooden frame and connected positive terminal of the battery at the top of the wire, and the negative terminal of the battery is connected at the bottom of the wire. Here placed 4 compass needles in a circular path around the hole so that its center coincides with the hole. Observe the needles of the compass. Then switch on the battery eliminator and current flows through the wire. Observe the direction of needles in the compasses. Now I am going to switch on the battery eliminator. Observe here. Here we are noticed that the compass needles are directed as tangents to the circle. Here what is the shape of the magnetic field line around the wire? It must be a circular. It must be a circular line. Observe once again. I am going to switch off the battery. Now I am going to switch on the battery. See the direction of needles. Magnetic needles are directed as tangents to the circle. So we conclude that the magnetic field lines are closed lines. The magnetic field lines due to straight wire carrying current are closed lines. This can be verified by sprinkling iron filings around the wire when the current flows in the wire. What is the direction of magnetic field line at any point on the field line? Here the positive terminal of the battery is connected at the top and the negative terminal of the battery is connected at the bottom. So the current flows in the downward direction from positive terminal to negative terminal. That means in the downward direction, that is into the paper, into this board, into the paper. The current flows in the downward direction. Let us sprinkle the iron filings around the copper wire. Before switching on the battery eliminator, observe the iron filings around the copper wire. Now I am going to switch on the battery eliminator. I switched on the battery eliminator now. Tap the board gently like this. Observe here circular lines formed around the copper wire. Here the current direction is the downward direction into the paper. The magnetic field direction is clockwise direction. It can be determined with the right hand thumb rule. See, this is a right hand thumb rule. If you grab the current carrying wire with your right hand in such a way that thumb is in the direction of current. So that is like this. The current direction is in the downward direction. See, like this. Thumb should be in the direction of current. Thumb be in the direction of current. If you grab the current carrying wire in such a way that the thumb should be in the direction of current. Current direction is in the downward direction. The curled fingers indicates the direction of magnetic field. See the curled fingers, this one. Curled fingers in this direction. Curled fingers are in this direction. That is in the clockwise direction around the copper wire. Around the copper wire in this direction. See the lines formed, magnetic field lines. Now observe, the positive terminal of the battery is connected at the bottom and the negative terminal is connected at the top of the wire. In this case, the direction of current is in the upward direction. So out of the paper, out of this board, from bottom to top. So it can be, what is the direction of magnetic field here? In this case, it can be easily determined with the right hand thumb rule. Grab the current carrying wire with your right hand in such a way that this thumb should be in the direction of current. See, like this. The thumb is placed in the direction of, the thumb is in the direction of current. Observe the curled fingers here. This thumb indicates the direction of current. Observe the curled fingers here. This is a anti-clockwise direction. The current flows in the upward direction. The direction of magnetic field is anti-clockwise direction.